Okay. All right, so the key with laws of logarithms is, first of all, they're directed to laws of exponents. Since logarithms, again, there's a way to write an exponential equation. It's either as a log function or just as an exponential equation. We looked at converting it there at 9 o'clock. Now, here's the key. Number 2, laws of logarithmic functions, is that the laws of logarithmic functions can be used to simplify logarithmic expressions if all the logarithms have the same base. So that little number that when you just see log, it's a little 10. They have to be the same, or none of these laws work. You can't do them. All right, so I'm going to go through some examples here. What do we have here? 6 examples. So example 1, A. It just says write each logarithm in the form r times log a to the power of x. So again, all this was, and this is the rule that we already looked at because we needed to solve. Right, so we just have numbers this time, no letters. And so all that log rule is saying, it's our first log rule, is if you have an exponent on this number inside the log function, we can bring down the 3. And there's our answer. And again, there's our base, that little 4. That's all that's saying, is we can convert it. We can take that exponent out and move it down in front. That's all that log rule is saying. So again, B, if we have the log of, with a base of 5, as they say, 625 to the power of 2. Again, that first log rule that we've already used is saying bring the 2 down in front of the log and get rid of the exponent. All right, so that's all that's saying. Example 2 now. This involves our other 2 logarithmic functions, which is the sum or difference of logarithms. And so example 2, we are looking at, let's see, A, for instance, where we have the log of 5, or sorry, log of base 5, 25 times 16. Now, honestly, there's a little bit of a typo here in this second example, is that actually this should be in brackets. That's all. But all that's first, so it's the second log rule I'm looking at here, is that if you have 2 things multiplied inside the log function, I could rewrite this as log, and it has to have a base 5. They both got to be the same here. 25 plus the log, again, base 5, 16. So I can separate them. All these rules are to be able to separate our log functions in case we want to solve, or put them together to simplify things. That's what we're going to do with these log functions, or these log rules, or laws, I guess I should say. Let's see here. I'm going to go with C because that's a little bit different, where we're looking at 2 things being divided. So we have the log with a base of 8. In the brackets, we have 10 divided by 3. And so what I could shift that to is the log of base 8. Now, here's the key, is the numerator has to come first. All right? When we're doing addition here, it doesn't matter. But division, it does, because the numerator and denominator make a difference. And so I got to write the numerator first. And again, because it's division, it's actually going to be subtraction. All right, log of base 8, and we have a 3. So again, there's an example of where we're taking a log function and we're splitting it apart. Okay, let's see. Now in example 3, we're going the opposite way. We are going to put them together. That's the whole point here. All right, so let's go A and C this time out. All right, so again, A, we're working in reverse, where we have the log with a base of 3, 81, plus the log base 3 of 9. There we are. Okay, and so what I look at is I want to put them together. Plus sign means that when I put these 2 together, the 2 values, 81 and 9, will be multiplied, not divided. All right, so I have a log of base 3, and again, because it's plus, I have got to put it in brackets, 81 times 9. Actually, I think I can figure that out. We get 729. So I have the log base 3 of 729. All right, and we could actually figure that out. 3 to the power of something would give me 729, but that's not what we're trying to do here. All right, a little more involved. C, what do we got here? All right, a little bit of a bigger one here. So I have the log base 2, 64 minus, and in square brackets, I'm going to run a room here, darn. Log base 2, again, they all have to have the same base. 16 minus log base 2, 4. I know you probably can't see that. Hopefully you're following along in your notes. All right, so again, bedmiss. I'm going to do with some brackets first. And so I'm going to leave this first part alone. Log of base 2 was 64 minus. Now, in these square brackets here, again, minus sign. So when I put these two together, combine them, we're going to have division inside the log function. All right, so again, I'm going to have the log of base 2, but it's going to be 16 divided by 4. All right, because again, the first term's in the numerator, second one is in the denominator. Now, we actually know that that is going to be, well, I'll rewrite it here. So I got the log base 2 of 64 minus the log base 2 of 4. All right, that's just, I just simplified 16 divided by 4. Again, to further put these together, because they have the same base, I can do that. A minus sign again means we're going to have division. Use the division logarithm rule, law. All right, so again, log 2. I'm going to have, again, the numerators first, denominator second, 64 divided by 4, which I believe can simplify down to the log base 2 was 16. And I could actually, you know what, solve that. Because what that is saying, and I don't think I did this in my notes because it's not asking us to, but if I ask to simplify that, 2 to the power of what gives me 16. That's what that's saying if I convert that logarithmic equation into an exponential equation. And the answer would be, or x is equal to 4. Again, we didn't, that's not what it's asking, but yeah, just a little review of what we did earlier today. All right, so now I'm going to do example 4 here. Just have to do a little clean up. All right, so what do we got here? Example 4, evaluate. Okay, so we are taking a step further. Let's see here. Let's go with, I'm going to do A and D, just to mix it up. Example 4, A and D. Get dry. There we go. All right, so now it says, just well, like I did the last time there, I'm going to jump the gun on myself. Evaluate the following logarithmic functions. Again, nothing in the chat, so we're good. All right, so example 4. So we're going to use our logarithmic rules to put things together and then figure it out. So I got the log base 5 of 125 plus the log of 5, base 5, sorry, and 5, minus the log of base 5 and 25. All right. Now, what I can do is put this all together at the same time. Again, when I'm putting them together, the plus sign is indicating that inside the log function, they'd be multiplied. The minus sign is saying when I put them together inside the log function, it'd be division. All right. So again, they all have the base of 5. I got 125 plus log and the 5's there, so I can really take that as inside the brackets 125 times 5. And then down below, because I got a minus sign here, combining, divided by 25. All right. Let's see here. So I got the log of base 5. I simplify that. So let's see here. 125 divided by 25, I believe, is 5. Then times this 5, I would get 25. And say we want to know what this is equal to. So I'm going to say, well, we don't know what it's equal to. It's equal to x. And this, again, when I'm solving for a logarithmic equation, I can flip it into an exponential equation. There's my base. There's my my exponent. There's my answer. And so 5 to the power of what will give me 25? answer is 2. All right. Again, that was A. What did I say we're going to do? D. I guess D here. So now I have the log, base 4, 32. Actually, the way you say it is, I should say I got the log of 4 with a base 4, and then minus the log of 16 with a base 4. Again, they all have the same basis. Has to happen. You can't use any of these rules. All right. And so let's see here. So again, when you have plus, that means inside these two are going to be multiplied, and when we have subtraction, they're going to be divided. So I could, again, I can say this is x equals. I want to figure out what this whole thing equals. The log, base 4, I get a 32 times the 4 on the top, and then divided by 16. All right, let's see here. Now I keep going. I simplify inside the log function. 32 times 4 divided by 16. Let's see here. I get an 8. There we go. And again, converting it. There's our base to an exponential equation. I should say, there's our base. There's our answer. And what is our x value? Now, this one's not obvious, right? 4 to the power of 1 is 4. 4 to the power of 2 is 16. So what I could do to solve it, because I'm solving for an exponent, right? Hence why we did day 8 first. Take the log. Take the log of both sides. That'll help. So then using my log rule, I have an x down in front. The log of 4 equals the log of 8. The log of 4, I could find that out again using my calculator. Let's see here. Log 4, 0.6. Log 8, 0.9. Divide by my numerical coefficient here of 0.6. And so if I get 0.9 divided by 0.6, I just get 1.5. So again, that's a way of taking a great big log equation, using our log rule, simplify it, again, converting it using exponential equations, then using our log rules again, our other log rule, to actually solve what's going on. All right, what do we got next here? That's 4. Let's do 5. Let's see here. Let's go with 5. I'm going to go with 5b. It's the biggest one. All right, so I'm going to wipe down here again. All right, so again, example 5, switching it up, we'll go with B. And B says, write each, or number example 5, write each expression as a single logarithm, combining things, right? So I have, let's see, I've fixed this note, want to make sure I write it down right. Yeah, okay. All right, so I have 1/2 log base 4. 64, again, I'm saying that wrong. It should be 1 and plus 1/4 times the log of 16 base 4. There we go, said it right. Minus the log of 16 base 4. All right, so again, I'm going to use my logarithmic rules to combine these two. Again, that's why we're using these exponential laws, either to pull things apart or put them together, or in fact, even to solve. All right, so that's the main goal here. Now, first off, I'm going to use that first log rule twice in reverse of what we've been doing. So I have the number up front. I'm going to put it up top. So I'm going to rewrite this first as log of 64 to the power of 1/2. All right, base 4 plus log of 16 base 4 to the 1/4 minus the log of 16 base 4. All right, now I can simplify this. 64 to the 1/2. Now, I'm not sure how many of you did this in grade 11U. Again, who knows what happened last year with COVID. But when you have something to the 1/2, that it just means the square root. That's all that means. You're finding the square root. And the square root of 64 is 8. Now, I get to 16 to the 1/4. Again, I'm not sure if you've learned this in grade 11U. You should have, but hey, I get it. 16 to the 1/4. That means you're trying to find the 4th root. That's how I would write it. That's how it's converted. The 4th root of 16, which means what number times itself 4 times? 4 times will give you 16. The answer is 2. And I got this power of the 1 here just to follow the exact rule. So it is 2, because 2 times 2 times 2 times 2 gives you 16. All right, so I have a 2 here. And again, I still have this log of 16 to the base 4. All right, now, again, using my log rules, right? Where we have plus sign means we're going to put these 2 inside the function, the log function multiplying, but yet this one's going to be division. So I've got log of 4, I got 8 times 2, and divided by my 16. And so I get the log of 4, 8 times 2 is 16 divided by 16. So it's a log of 1. And there it is written as a single logarithm. Could I solve that just out of curiosity? Flipping it into exponential equation. An exponential equation. Again, I'm going to say that we're trying to figure this out, so I'll call it x. Again, there's your base. That's my exponent. There's my answer. 4 to the power of what would give you 1? The only way that works? 0. So this big mess here is all just equal to 0. All right, so that's example 5B. All right, and then I'll do, example 6, the last one. Here we go. So let's see here again. Clean up. All right, so example 6, last one. So we have a great big log expression here. We have the log of the square root of x cubed times y squared divided by z. What's the base here? 6. All right. So essentially what this thing is saying, break it apart. All right, break it apart. Okay, so here's what we're going to do. Now, as I mentioned in the last example about rewriting things a little bit differently in terms of our exponents, when you have something that's square rooted, really what you're doing here is you're taking it to the power of 1/2. You're looking for the second root of it. Just like I have 1/4 was the 4th root. Well, square root can be written as to the power of 1/2. Again, I'm not sure how many of you cover that in 11U. All right, and so now what I can do is use my exponent rules, actually, where it's called the expanded power rule. I'm not sure how many of you did that in grade 9 back in the day. What it means is I have to apply the exponent to every single term in the brackets there. So my x term, exponent power of a power, I have to multiply. All right, and so what I have here is I have x to the 3/2, because 3 times 1/2. I've got y to the power of, 2 times 1/2 is 1. And then down below, I've got my, actually, you know what? I'm going to switch this up. I'm going to do it a little bit easier. Because, show you a little mistake there. Not a mistake, but easier way to do it. Use our first log rule. I'm going to bring the exponent down in front. Instead of applying it to all this stuff, I can just bring it down in front. So I have the log of x cubed y squared all over z to the base of 6. There we go. And so now what I'm going to do is rewrite this part in square brackets using my division and addition of log functions to split it up. Again, multiplying is going to be plus, division is minus, and so I've got 1/2. Again, I'm going to go square brackets because I'm going to expand the 1/2 when I'm done. So I've got the log of x cubed base 6 plus the log of y squared to the base 6. And then because the z is in the denominator, minus the log of z to the base 6. Okay. Now, again, I'm going to use that log rule where I bring the exponents down in front of the log. And so I've got 1/2. Again, that 3 is going to come down. So I've got 3 log of x base 6. Let's bring the 2 down here. So plus 2 log of y base 6. And then, well, I don't have to do anything with the z one. So we got the log of z base 6. And then my last step, like I said, I'm going to expand the 1/2 through. And so what I end up with is, let's see, 1/2 times this. I'm going to have 3/2 log of x base 6 plus, let's see, 1/2 times 2 is just 1. So I'm going to have the log of y base 6. And then lastly, 1/2 times minus 1. So it's going to be minus 1/2 the log of z base 6. So there again, I was using all of the rules to break our great big logarithmic function apart. I used the first law with bringing the exponent down, and then the other laws when we're multiplying logarithmic functions or dividing logarithmic functions. All right, so again, I hope this helped. If you have any questions, let me know. I'll stop recording.